Welcome, ladies and gentlemen, to the second of 6 videos over Chapter 8, Section 4 in your McGraw-Hill Geometry textbook, a very important lesson over SOHCAHTOA. Again, this video is going to have 2 additional examples of the final problem type that we looked at in the first video, which is shown here on the screen. The first of these 2 examples will have nice numbers, and the second example will have not nice numbers, so you can see what that looks like. Again, as long as you have your calculator, neither one of these should be incredibly difficult. Now, for our classes at Speedway High School, you should have a TI-30 XS Multi-View scientific calculator. If you don't have that specific calculator, then the items where I discuss how to put things into the calculator in this video session will not really apply. But, you know, it's, again, information that is generally widely useful. So, we're looking here at example 4, which reads write out the sine, cosine, and tangent of each acute angle in the triangle shown as both a fraction and a decimal rounded to the nearest hundredth. Now, as previously stated, this is really 2 separate problems. We need to write out the sine, cosine, and tangent of angle F, and then the sine, cosine, and tangent of angle H. That is going to involve the use of SOHCAHTOA. Again, SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So we go in and we locate the hypotenuse. G is the right angle. We go across the triangle. 13 is our hypotenuse. Then, since we're doing angle F first, we name the other 2 sides based on angle F. Now, based on angle F, our 5 is going to be our opposite side because it lies across the triangle from angle F, whereas 12 is going to be our adjacent side because it is next to angle F. I realize the hypotenuse is as well, but we've already named that side. So, when we go to do the sine of angle F, we are going to use our definition, which is that sine is opposite over hypotenuse. Now, given the labels that we have in our picture, opposite is 5 and hypotenuse is 13. So, the sine of angle F is 5 over 13. We check, and that fraction does not reduce, so that takes care of the fractional answer. We feed that to our calculator. 5 divided by 13 is approximately 0.384. Again, I'm looking at 3 digits because the directions tell me to round to the nearest hundredth. So I look at the thousandth digit, which is a 4, and that tells me to round the 8 down. In other words, leave it alone, which means the decimal approximation, according to the directions, would be 0.38. I'm going to continue this process for cosine. Cosine is adjacent over hypotenuse, which according to the labels I have in this picture right now, the adjacent is 12 and the hypotenuse is 13. So my cosine would be 12 over 13. Feed that to my calculator to get the decimal approximation because it does not reduce, so that is the fractional answer. And I'm looking at the decimal 0.923. Again, 3 is less than 5, so I would round that down to 0.92. Finally, for tangent, tangent is opposite over adjacent. So that would be 5 over 12. Again, that fraction does not reduce, so that is the fractional answer for the tangent. I just need to feed it to my calculator and get the appropriate decimal. That decimal is 0.41, and that third digit is a 6, which means I should be rounding my answer up to 0.42. Once again, the tricky part of this is that then I'm going to turn my attention to the other acute angle, which is angle H. And what happens when I turn my attention to angle H is that my labels change. 12 is no longer the adjacent side, 12 is now the opposite side. Whereas 5 is no longer the opposite side, it is now the adjacent side. Other than that, this work stays the same. I'm going to go in here and I'm going to set up my 3 trig ratios, just like I've done in the previous 2 examples, using my definition SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now again, the big thing here is that while hypotenuse 13 has not changed, opposite and adjacent have changed. 12 is now the opposite, and 5 is now the adjacent. So my fractional answers are there shown. Again, I should be feeding these to the calculator, but you'll notice that the sine and the cosine are values that we already have. 12 over 13 is 0.92. 5 over 13 is 0.38. For tangent, we don't need to round because 12 divided by 5 is exactly 2.4. Okay, we're going to take look at another example of this, and this next example is going to involve numbers that are not nearly as nice. But again, not all numbers in mathematics are going to be nice. So we have to be prepared for more difficult examples. And all we really have to do is know how to use our calculator, and we'll be good to go for now. We will get more practice in Algebra 2 with dealing with radical expressions. So, let's take a look at example 5 in our notes, which is a right triangle with 3 very not nice side length numbers. Our legs, xz and yz, have lengths of 2 times the square root of 3 and 4 times the square root of 3, which makes our hypotenuse 2 times the square root of 15. Now, the overall process has not changed. We still are going to look at this one angle at a time. We still are going to use SOHCAHTOA. None of that has changed at all. The only part that's changed is the level of calculator work that we have to apply here. So we locate the hypotenuse. Again, that is across from the right angle. So if z is the right angle, then the side opposite angle z, which is xy, is going to be our hypotenuse. We pick out one of our angles, starting with angle x, and we name the other 2 sides. So 4 root 3 would be our opposite, and 2 root 3 would be our adjacent. Then we set up our trig function. Remember that we have our definitions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Again, that is coming from SOHCAHTOA. Now, when we go to actually do these problems, we're going to run into some fairly heavy radical expression mathematics. Okay, our opposite here is going to be 4 root 3, and our hypotenuse is 2 root 15. Now, we're not going to delve into how to reduce these radical expressions and put them in proper notation in this video, because that's not a geometry lesson, that is an algebra lesson. Now, unfortunately, I know that those of you that had Algebra 1 last year didn't get this lesson because of the pandemic. So you just need to trust your calculator. Now, that being said, on the TI 30XS Multiview, here's how you would input 4 root 3 over 2 root 15. These are the keystrokes. We would start by hitting our fraction button, N over D, which is located 3 buttons above the 7. In the top, we're going to type in 4 root 3. So we'd hit 4. And then to get the square root symbol, we would do second x squared. You'll see the square root in green directly above the x squared symbol. And underneath, we'd type our 3. We then go to the circular D-pad at the upper right, and we hit the down arrow. That moves us to the bottom of the fraction. On the bottom of the fraction, we would similarly enter 2 times the square root, which again is second x squared, of 15. After we do that, we simply need to hit enter, and the calculator will carry out the appropriate reduction for us. So, once you've typed that in, you should get 2 root 5 over 5. Now, if you do not have a math print button on your calculator, you will not be able to get, if you do not have math print on your calculator, you will not be able to get the radical expression reduced. That's okay, because you will still get the correct decimal answer. Okay? So to get the decimal answer, you would then push the convert button, which again looks like a pair of double arrows and is right above enter. It's like this. Hit that button. On some calculators it says S to D or F to D for fraction to decimal, standard to decimal. Okay, either way, when we convert 2 root 5 over 5 to a decimal, it is 0.89, and that third digit is a 4. So we should be looking at the decimal 0.89 for the sine. For cosine, we would have 2 root 3 over 2 root 15. Again, you're going to feed that to your calculator using the same basic instructions, fraction button, 2 root 3 on top, 2 root 15 on the bottom, and hit enter. It should print out the reduced answer, which is the square root of 5 divided by 5. Then we hit our convert button to get the decimal, 0.447, which means we're going to round it to 0.45. Finally, for tangent, that would be opposite over adjacent, which would be 4 root 3 over 2 root 3. And that one, you may recognize, the root 3's would cancel. 4 divided by 2 is just 2. So it doesn't require a decimal and a fraction because it's a whole number. Again, you could type that into your calculator. You will get 2. Again, that's the only part of this that's any harder, because then from there, we just turn our attention to angle y, which again is going to cause 2 root 3 to become the opposite, because it's opposite of angle y, and 4 root 3 is going to be our adjacent. Then we're going to go in and set up our 3 trig functions again, using SOHCAHTOA. Okay, again, SOHCAHTOA states sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Again, we're using the blue labels instead of the red labels now. So opposite is 2 root 3 over hypotenuse, which is 2 root 15. We've already done that math. There's no reason to need to do it again. We should know that that reduces to root 5 over 5 for our fraction. And we know that the decimal is 0.45. For cosine, that is 4 root 3 over 2 root 15. Again, we've already done that math. We should not need to do it again. That is 2 root 5 over 5 for the fraction, and is equal to 0.89 for the decimal. Finally, for tangent, opposite is now 2 root 3, adjacent is 4 root 3. So instead of reducing to 2, the root 3's would still cancel, but then we have 2 over 4, which is equivalent to 1/2, or the decimal 0.5. Okay, so that is how we deal with radical expression side lengths. It's not a big deal. We just have to lean on our calculator a little bit more. If you have any questions on how to do that, see me and we'll get it hammered out. If you're not getting these answers, definitely see me, because that means your calculator requires a little bit more TLC to enter your answers. We got one video left for 8-4A. It's going to be a very short one over how to evaluate sine, cosine, and tangent values with your calculator. Thank you very much for your time and attention.